I'm Anil Kumar, and here is an excellent video for you to understand how to sketch graph of first derivative. Question is, use features of function's graph to sketch the graph of its first derivative. Now this is not an easy graph, it's kind of very complicated, but we are given graph of a function f of x. So let's call this as f of x, and now we need to sketch graph of its derivative. That means f prime x, right? So how can we do that? Whenever you want to sketch graph of a derivative, you should first look for turning points. So this is a turning point, that is also turning point. Tangent slope is 0. That means for the derivative at this point it should translate to zeros of the derivative, right? So for the derivative it should be 0. So we get 2 points on our graph which happens to be 0. Now that is first thing. So let me write down these 2 points, that is turning points on f of x result into zeros on f prime x. Okay, so that's one thing which we have learned. Second is we should see the concavity. So if it is concave up, that means that the function is positive, right? So if it is concave up, the derivative is positive, right? Because the slope is rising and it's increasing, correct? So what we see here is this part of the function is concave up, right? So this part is concave up. At this point it kind of turns like this. So but up to this point we can say that to be point of inflection, right? So what we observe here is there is a point of inflection, but here what we observe is that the derivative is increasing, right? So concavity. So whenever it is kind of concavity is, let us say, concave up, so that really translates to the derivative is increasing, right? So that is, I'm trying to show you it is increasing. Do you get the idea, right? So it is increasing. We need to appreciate that at this point derivative is 0. So it will increase to some point and then decrease, correct? So at the point of inflection it is still positive. The tangent which I draw here will be positive, right? So it is concave down, right? This portion is concave down. So when we say concave down, in that case derivative is decreasing. Decreasing doesn't mean negative, remember that part. Decreasing means it is lesser than what it was, correct? So at point of inflection, it really means that at point of inflection where the concavity changes, at that point the derivative is maximum. Do you see that? Especially when it's going from up to down, that's maximum, or it could be minimum also if it goes from down to up. That's the concept. So what we have here is a maximum for the derivative. So what I will do here is say, well, this is my kind of turning point for the derivative, right? So that is my maximum. So that is another thing which we learn. And now third and foremost is very simple, that if we have a flat portion, like kind of a horizontal line, right? A horizontal f of x results into 0, right? Derivative, is it okay? For a constant the derivative is 0. So what we are saying here is that it approaches horizontal, so our function also approaches 0 here. So based on these things we can say that the graph of the function should be kind of like this, turning from there and then kind of going down at this point. You get the idea, right? That is how it should be. So we got one part of the derivative. Now we can do the same strategy on the right side and get the other half of the derivative. I'd like you to pause the video and then do it on your own and then look into my suggestions. Correct. Let's move further. If you move further, what you see here is that the function is concave down here and concave up. So at this point, we again have point of inflection. Now this point of inflection is basically where the derivative is changing from concave down to concave up. So when it changes from down to up, we expect a minimum, right? So at this point, we have a minimum. So let us say that is our minimum, right? Values we are not very sure of, but we know that the derivative is minimum at this point of inflection, as we explained earlier, right? And we know it is 0 here, so it will turn. So we'll join these 2 points and go through this, correct? So it will turn and go through this, which is 0 slope, right? Do you see that 0 slope? Right. So that is how it is going to be. Now, after this point, if you draw a tangent line, it is positive, right? So it is positive. We have crossed the line already. It is positive, concave down, right? Do you see that concave down? So if it is concave down, the derivative is decreasing. That means it is not that steep, right? But it is positive. Since it is not that steep and it's positive, we know at this point where there is a change of concavity, we are going to hit the maximum. So the maximum for the derivative from the symmetry we can draw here will be kind of there. So it should be turning from here and then approaching to 0. So we can say approaching to 0 kind of like this. So that becomes the graph of the derivative. Now let me draw the whole graph in one ink. So it should be kind of like this. Do you see that? So it is decreasing, going to the minimum, right? Increasing, approaching the maximum, and then dipping down to 0, kind of like this. So that is how we could sketch the graph of the derivative of the given function. I hope that helps. Thank you and all the best.